Well, good afternoon. Against the advice of our marketing department, I wanted to talk about the aggressiveness about what we had to do to make this whole digital infrastructure thing happen, and so wanted to use the imagery from Saturn V and the trip to the moon because this is about as that complicated. And so we went ahead and did that, and I was incredibly surprised. I got back to the room last night, turned on the TV, and the SLS finally launched, for those of you that are space nerds. So that's awesome. We are on our way to the moon right now. So a very good sign. And it took off from Launch Complex 39. So I think we all know that we've got issues in terms of matching public and private interests in coordinating around mobility and transportation. We've been trying really hard and made a lot of progress, but there's a lot more work we have to do. While we've been working hard, private industry has been flying. So they've got money, they've got technology, they've got resources, and so we've got connected vehicles, we've got digital twins all over the place, dynamic pricing, digital routing. They're off to the races, which is terrific. The problem is the public sector hasn't kept up. And the price that we pay for having this discontinuity or this mismatch between the private and the public sector is enormous. All you have to do is look at the amount of time, for instance, freight delivery vehicles spend driving around a city looking for burning fuel, risking parking fines, and burning time and labor, and that number gets to be really, really large on a global basis, all down the drain. So there's a lot that we can do both to optimize for private sector spend, and there's a lot we can do for social externalities. This is a statement from Huntley Loris, who's the Chief Operating Officer for the Port Authority, which I like a lot. I've spent billions on concrete and nothing on optimizing the use of that concrete. I'll add that when Huntley spends $1 billion on concrete in the Port Authority, it doesn't help Justin Urbacci at LAWA at all. However, if Huntley spent $50 million on digital infrastructure, it could help LAWA immediately. So there's a lot of leverage if we could figure out what this digital infrastructure is and actually make it happen. Just to give you a rough idea about how DOT is currently thinking about it, here's about $284 billion of incremental spend in IIJA, and it's for things you see here: roads, airports, ports, waterways. You never see the word digital anywhere in that list. And you could say, well, the DOT is doing these smart grants, which is a $500 million program, which is 1/500th of what we're spending on digital infrastructure. And then we're taking that 1/500th and we're dividing it down again to 20 to 30 grantees. So it becomes a relatively very small number. And so if we do a really good job in 5 years of these smart grants, we'll have 20 to 30 pilots or proof that some ideas might work, but we'll really be no farther down the road towards a unified national view of digital infrastructure. So we're not on a path right now to get this done. And it's going to get worse. There was a panel this morning on AAM, but to date, US DOT, FAA have been the responsible agency responsible for handling how aircraft interact with the populace. And they do that typically with 1 or 2 touch points in a city or a city area called an airport. Well, what do we do when these vehicles are integrated into the fabric of the community and landing and taking off potentially anywhere? How are we going to decide what standards would control how cities and these aircraft would talk to each other? And then what kind of policy should we put in place and what kind of legal constructs will enforce all of this? All of this stuff has to be worked on, and right now people are thinking about it, but no one's really addressing it, and especially not addressing it in terms of a digital infrastructure. So I want to talk for a minute about a reference model. So in the tech industry, an example would be work around what we now know as the internet. Back in the late 70s, ISO, an organization, got together and said, you know what? an HP computer can't talk to an IBM computer, can't talk to a DEC computer. We need to have some standardization, some way that all these devices can talk to each other. And so they developed something called an OSI stack, which was a really good idea at the time and was a roadmap for how we could get so the industry could all talk to one another and we could start having networking. In the 80s, the federal government got involved and said, oh, Netscape is doing some interesting things. This could be a really big deal. We're going to create name servers. We're going to create DNS. We're going to put in place the pieces that it would allow all this fledgling internet stuff to, all this fledgling networking stuff to be turned into what we now know to be the internet. Really big idea. And today, because of that work, which is a combination of what the private industry did and the government, we have what's called the internet and trillion-dollar industry. So super important, but at the core of what went on there was the establishment of a reference model. So what this reference model does is it gives both consumers of the services like cities or states as well as the industry players a framework. So if we build a reference model and it works, what does it look like? First of all, we can talk about it to ourselves or to anyone else who cares, and they can understand what we're talking about. So it needs to be easily digestible and be able to be communicated to a wide variety of audiences. Secondly, it has to work, in the case of transportation, from the very smallest city that you can imagine, all the way up through large metropolitan areas, MPOs, counties, states, and even sometimes the federal government. So you have to have a system that's capable of scaling over that entire range. Third, this reference model needs to incorporate not just the ground, but also the air, as we talked about earlier. Fourth, we've got to be able to easily unlock federal spending. So what happens when you have a model that has discrete components, the federal government can look at that and say, oh, gee, we're behind in this particular area of technology. We're going to dump some program dollars into encouraging industry to go after this particular area. So by breaking the problem up, which is normal, it's a huge scope required, but by breaking it up, now we can enable federal funding much more easily. 5, we've got to have, in any reference model, interoperability standards. So if you have various categories of technology that have to all work together to make this thing happen, the way they talk to each other has to be standardized. So you could have one piece of technology in this reference model, or I'll call it a stack, and you could pull out that vendor's technology, and you could put in another vendor's. That does a couple things. It allows there to be a lot more competition, so companies can get in with a lower cost to get started, as well as it encourages innovation because everyone is competing. Interoperability standards is really important. There are a bunch of companies, some of them here and elsewhere, who are already in business today building technology, offering pieces of this reference model, and the reference model that gets developed has to contemplate that they're not going to go out of business. It has to give them the ability to not only compete where they are today, but also extend in the future the business that they could entertain. So swim lanes are important for existing vendors. And 7 is the most important, which is the reference model needs to contemplate that there will be applications. There needs to be a layer that is specifically made for a wide variety of software developers and creative people to say, I think I could add value in this particular area of how a city or a state operates. All we have to do is look at the Apple Store. There are now 3.2 million applications in the Apple Store, and that's what happens when you have APIs and a reference model that encourages applications. So I was in a conference a couple months ago, and the US DOT said, well, whatever we do, we have to do it in a way that we can leverage industry. We can actually get the commercial power of the United States behind what we're doing. Number 7, an application standard is the way that that will happen. And then finally, this is not going to be, we can talk about it in the context of the US, but this is not going to be just a US reference model or an implementation. In the future, a BMW is going to have to work in London, it's going to have to work in New York, San Francisco, and Singapore, which means that there has to be a standardization that is actually a global standardization. And this is enough work that you're not going to end up with 5 or 6 different countries foisting their reference model on the world. And so right now, there are some cities or countries, like Singapore is clearly in the lead, who have spent a lot of time thinking about this. And we can choose to go as we are, which I'll say is not very organized. And we're going to end up implementing and following another reference model from some other area that became dominant. So it's actually an important area for US competitiveness that we get our act together about this reference model. So because I've spent a bunch of time in tech, I'm going to use a tech-derived version of a reference model just to throw out there, not to say that this is what we need to do, but to say this is how we might want to think about it. So as a sample, so here's an 8-layer model. Layer 0 is the physical layer. So this is roads, airspace, could even be areas underneath roads. Layer 1 is transportation sensing and services. So this is loop detectors, cameras, traffic signals that output information to people who are using the public right-of-way. So that's all the interface between consumers of the public right-of-way and the system. Second, layer 2 is transportation control system. So think of this as the box that sits at an intersection. So it's usually localized control, grabbing a bunch of data from layer 1, doing some processing, figuring out what they need to do, adjusting signal timing, and then outputting it back to layer 1 to control the signal. Layer 3 is now starting to think about network optimization, because what networking really means is you're going to take all of this local information, some of it processed locally, some of it coming all the way back to a centralized location or cloud. You're going to take all of that data and make it available to look at and to figure out what's going on. A perfect example of that is right here in LA with ATSAC. They've done a beautiful job of implementing a layer 3 system. Layer 4 is probably the most important. So a transportation operating system. I'm sure you're familiar with what an operating system does in a computer, which you've got limited RAM, CPU, I/O, whatever, and you've got any number of applications that you're running on top of that computer. And what the operating system does is says, don't worry, I got you. I will allocate the technology that I have so that your application is happy. And you could have 50 applications all running simultaneously. The operating system take care of it. Well, that is exactly the problem that we are facing at a high level in cities today. So we have a limited set of assets. We have curbs, we have streets, we have airspace, and we have any number of mobility consumers or companies that want to consume that airspace or that street, those streets. And so how do we decide who gets to do what? How fast do they go? How much do they pay to park? What is the priority for anyone that wants to use that asset? Today, that's largely handled by the DOT, and they issue standards or laws, and they put up signage, and that's the way it goes. But as the world becomes more dynamic, and you have all of these real-time inputs, now an operating system can enable those decisions to be made in real time. Now, just like an operating system in a computer doesn't really make decisions or know what to do, the applications that sit on top of it do the work. And so the next layer up, applications, is where, as I said earlier, all the innovation will happen, but it's where today you could have visualization services so you could see what's going on. You could have pricing optimization application for parking. You could have airspace optimization based on noise standards that neighborhoods have. Those are all applications that would come into existence, and the best and the brightest would recognize this. It'd be kind of fun, and I think that you'd see a ton of innovation in this area of software applications. A lot is made whenever we talk about systems and technology around transportation, around data. Data is the big deal. Data is not really a thing in itself. It is a component of what needs to happen here. It is conveying information, but data itself doesn't do anything. in most cases, when people are thinking about data nowadays, they're thinking, oh, I will look at the data and I will be able, as a person, I'll be able to make a conclusion and then change some policy perhaps. Well, all of that's going to now happen in real time. So data is a component, and we need to be very careful about how we handle data. How long do we store it? How do we make it available? Do we anonymize it? All of those data and data services would exist in layer 6. And then layer 7 is, think of this as, for those of you that know the tech world, DNS. It's sort of at a high level, how do cities talk to each other? How do cities talk to counties? How do counties talk to the states? Because there will be transportation modes and mobility devices that cross these borders, and there needs to be a way, in a network way, that all these things talk to each other. So, as I said, this is just a sample proposal, but this is the kind of thing that would allow us to actually build something that would last for decades, would have the impact, quite frankly, that the internet had on the world, and would allow us to really begin to innovate again. If we do all this and make it happen, especially at a national scale, we're going to give the tools to cities, counties, MPOs, states to actually go after the environment, equity, safety, resident satisfaction, because now they're not in the business of pounding signs in the ground. They're in the business of talking about outcomes that they're looking for. And that wonderful technology stack, or a version of it, is going to actually make those decisions for them. So it's a super important concept, and it has a lot of issues. So I'm going to invite my panel friends up here in a minute, but just to sort of set the table a little bit. So for instance, this is not just a city thing. And we're huge supporters of Andrew and the OMF, and we love the OMF, but the OMF is one component. States also have to be a part of this, and to a degree, the federal government needs to be a part of it. And historically, sometimes cities and states don't collaborate as well as they might need to make this happen. So how do we encourage that collaboration? How do we get states, who quite frankly have the bulk of the money and the technical resources because of the money they have, to contribute to this? How do we get them on the same page as cities, working together to solve this problem of digital infrastructure? So there's an interesting issue for us to think about. The next is, by talking through that stack, hopefully I've made it clear that this is a complex meeting of technology and transportation. And typically, the transportation sector doesn't understand a lot about technology, and I can guarantee you, having spent 40 years in tech, technology does not understand a lot about transportation. And so somehow we've got to come up with a mechanism that these two super important constituencies, which will marry and knit this together into something that really works, actually do that. So how do we encourage that kind of collaboration? So, 2 problems at least ahead of us. We're actively working with US DOT, ITSA, and others to really raise the level of conversation so that the country itself starts to think about what this opportunity could mean and how it might happen.